Hello, good evening to all of you. We are the group 4 presenters. So let's now proceed to our topic, which is controlling and auditing data management systems. As previously mentioned by other groups, a data management system is a vital feature of database approach because it provides a secure environment for assisting or preventing database access and efficiently managing data resources. Access controls and backup controls are the two types of data management systems. Access controls prevent unauthorized users from reading, retrieving, corrupting, or destroying the entity's data. In the event of data loss due to unwanted circumstances, backup controls ensures that the organization's database can be retrieved. Let's take a glance at the first type of data management system, which is the access control. The purpose of access controls is to ensure that only authorized personnel have access to the firm's data. Therefore, access controls play an important role in safeguarding the data from corruption, theft, misuse, and the destruction of itself. The first type of access control is the user views. User views restrict the user's access to a specific collection of data, and they don't define task permissions like read, delete, or write. Users' access to the database should be proportional to their genuine needs. To better understand, Figure 4.20 illustrates the roles of user views. Account number, client name, amount, and credit limit may all be accessible to user Smith, Jones, and Adams. Suppose that everyone has reading access to the data, but only Jones has the ability to modify and delete the data. Data encryption is another type of access control. As previously discussed, encryption is the process of converting data into a secret code for storage in databases and transfer over networks. Database systems also employ encryption processes to safeguard highly sensitive data such as product formulas, employee pay rates, password files, and some financial information, rendering it unreadable to an intruder browsing the database.
Another type of access control is the database authorization table. It provides rules that limit what a user can do. This strategy is identical to the operating system access control list. As previously stated, Jones, Smith, and Adams all have access to the same data attributes via a common user view. But database authorization demonstrates whether these users are allowed to perform a certain action. Let us look at Figure 4.3 to get a better understanding of the subject. Figure 4.3 shows that only Jones has the right to modify and remove the data. Having a letter Y in the table indicates that he is permitted to do so. N, on the other hand, denotes that they do not have the authorization to do so. This security measure signifies that an individual may not be able to execute something with the information even if he has access to the data. In turn, it would help in protecting sensitive information and records of an organization. Then, the next control is the user-defined procedures. Password is one of the company's security procedures for protecting files related to their business operations. However, there is still risk that hackers and other people within the company may access information even with the presence of password controls. This is where user-defined procedures come in. A user-defined procedure allows the users to build a personal security program or routine that is more reliable than a single password in terms of user identification. As a result, in addition to password, the security method also asks a series of personal questions, such as the user's mother's maiden name or anything personal to the user, which should only be known by the authentic user. Moreover, biometric devices can also prevent individuals from unauthorized actions. The use of biometric equipment which assesses various personal traits such as fingerprints, voice prints, retina prints, or signature features is the ultimate measure of user authentication techniques. These users' characteristics are scanned and permanently saved in a database security file, or on a user's identification card. When someone tries to access the database, a specific scanning equipment takes their biometric traits and compares them to the profile data on file or the ID card. Access is denied if the data does not match.
There are users that may need information from the database. For what? Basically for their decision-making purposes. How could they get this information? By asking each encoder, employee, user? No, users could use the query features of the database. But there are lots of information that the database could give you. Good thing that the database query capability provides users with summary and statistical data. Inference controls help prevent users from inferring through query features specific data values that they are otherwise unauthorized to access. To help you understand this further, let's take this payroll database as an example. Here, we all know that the salary field in the table is confidential, but for research or decision-making purposes, a user may need this information. If there are no inference controls that are in place, this user could determine the salary of Mary Swindle, a staff lawyer, by making the following queries. How many lawyers are female, and what is the average salary of all female who are lawyers? The database will say 1 and 65,000 respectively, which should have been kept confidential. This sort of compromise may be prevented by implementing an inference control that restricts the size of the query set. However, a determined and creative user may easily circumvent or bypass this control with the following queries. First, what is the total salary for the payroll database? The system will then respond $555,000. What is the total salary for all not lawyers and not female? It's $490,000. From the second query of the user, it means that the total salary for all lawyers and also female, which is only Mary Swindle, is the only amount left out. By subtracting $490,000 from $555,000, the user can determine the salary of Mary Swindle, and preventing this compromise requires further restrictions on the query set size by an additional inference control rule. Under this rule, neither query would have been satisfied. Inference controls attempt to prevent users to determine the specific value of a data item, that a data item does not have specific value, and to estimate the value with sufficient accuracy that would violate the confidentiality of the data.
The audit objectives relating to database access. First, we need to verify if the authority and the privilege of users are in accordance with their legitimate needs. The following are the audit procedures for testing database access control. First is the responsibility for authority tables and sub-schemas. We need to verify if database administration personnel retains exclusive responsibility for creating authority and assigning user views. Second, appropriate access authority. Select a sample of users to verify if their access privilege to authority table is consistent with their job description. Biometric controls. This is the most appropriate with highly sensitive data and with a limited number of users. Fourth, inference controls. It is used to verify if query controls exist to prevent unauthorized access via inference. Lastly is the encryption controls. We need to verify if sensitive data have passwords and are encrypted properly.
Businesses that wish to recover from disasters such as fires, floods, or even program failures must ensure that they have policies or procedures that the critical files are backed up on a systematic and regular basis. There are available backup controls in a flat file environment. Media type and file structure will have an impact on what backup method shall be used. A technique known as a grandparent-parent-child is used to back up sequential files on both tape and disk. The master file update procedure necessitates the use of this backup method. This figure shows how to back up sequential file batch system using the GPC backup technique. When the transaction file is processed against the current master file, they form a new master file called the child. Then the child will process against a new transaction file, then they form a new child. The former child is called the parent, then the original master file will call the grandfather. With each new batch of transaction, this process is repeated, resulting into a never-ending stream of backup files. The oldest backup file will be deleted once the desired number of backup files is reached. Using the most recent backup file against a corresponding transaction file will allow you to recreate the current file or the current master file if it has been corrupted or destroyed. For each application, the system designer determines the required number of backup master file. Both the system financial importance and the volume of the file activity weigh in on this decision. As an example, a daily updated master file may require 30 to 40 generation of backup. when a monthly updated master file may only necessitate to 4 or 5. Taking this step is critical in the event of a system failure, which could lead to the loss of numerous backup copies of the same set of files.
Now, let us discuss about the direct access file backup. Here, the data values are changed in place through a process called destructive replacement. When we say destructive replacement, once the data value is changed, the original value will be destroyed. And to provide backup, direct access file must be copied first before being updated. The timing of direct backup files will depend on the processing method being used. For example, in batch systems, backup of files will be done prior to the update process. If the current master file is being destroyed because it was corrupted by a program error, the master file will still be recovered from the most current backup file. However, in real-time systems, since the transactions are being processed continuously, the backup of files will be done at a specified intervals throughout the day. For example, every 10 or every 15 minutes. In this case, if ever the master file is being destroyed due to the same reason, the transaction since the last backup and prior to the failure will be lost and will need to process again. Therefore, if we will summarize it, doing the backup process is more difficult in real-time systems compared to batch systems. Next, when we say off-site storage, the backup files that were created under both GPC and direct access approach should be stored off-site in a secured location. So, what is the audit objective relating to flat file backup? The audit objective is to verify that backup controls are effective in protecting data files from physical damage, loss, accidental erasure, and corruption. On the other hand, in order to achieve the said objective, here are the 4 audit procedures for testing flat file backup controls. First is the sequential file backup. Here, an auditor selects a sample of system and determines if the number of GPC backup files specified in each system is adequate. If not, recovery is impossible. Second, the backup transaction files. Here, an auditor will verify through a physical observation that the files used to reconstruct the master file is also retained. Third, the direct access file backup. Here, an auditor selects a sample of application and through the system and observation, the auditor can verify that each of them are being copied first before updating. And last is the off-site storage. Here, an auditor should verify the existence and adequacy of the off-site storage. This audit procedure may be performed as part of the computer center operations controls.
The timing of the direct access backup procedures will depend on the processing method being used. When it comes to data processing, there are more ways to do it than ever. Your choices include real-time and batch processing. How you do it and the tools you choose depends largely on what your purposes are for processing the data in the first place. Figure 4.22 shows real-time processing and batch processing. The first one is real-time processing. It requires a continual input, instant processing, and steady output of data. Real-time systems use time backup transactions processed between backup runs will need to be reprocessed after restoration of the master file. The next figure is all about batch processing. Batch processing is even less time sensitive than real-time. In fact, batch processing jobs can take hours or perhaps even days. Batch processing involves 3 separate processes. The first one is data collected, usually over a period of time. Second, the data is processed by a separate program. The third one, the data is the input. Examples of data entered in for analysis can include operational data, historical and archived data, data from social media, and service data. In a batch processing system, using direct access file, the master file is backed up before the update runs. Backup of files in batch systems is usually scheduled prior to the update process.
If we were to take a look at figure 4.23, we can see that there is a centralization of data under database management system. Because of this, the system is prone for damages from individual users. As a result, the organization have to reconstruct the database into pre-failure status with proper backup system for it to work. As we go further, this system provides 4 backup and recovery features: database backup, a transaction log, checkpoint, and a recovery module. For backup, it backs up the entire database on a daily basis and should be carried out automatically that should later on be kept in a safe, distant location. Second is the transaction log journal. This feature keeps track of all the transactions that have been completed, which then separates transactions in a transaction log file and the database modifications in a database change log. While the system reconciles the transaction log and database change log, the checkpoint capability suspends all data processing. Checkpoints are triggered by the system on a regular basis. If a failure occurs, the processing can generally be restarted from the last checkpoint. As a result, only a few minutes of transaction processing will need to be done again. Lastly, the recovery module is used to log and backup files to restart the system after a failure. Actually, there are audit procedures for testing database backup controls. Auditors must determine that backups are performed on a regular basis to make it easier to retrieve data that has been lost, captured, corrupted, or damaged, without requiring extensive reprocessing. The backup policy should strike a balance between the inconvenient nature of frequent backups and the business disruption caused by the extensive reprocessing required to restore the database following a disaster.